Yeah, so as Maria was saying, today we'll be talking a little bit about like how our engineering teams, how we can cultivate a developer-centric culture around continuous improvement. Before we get into all of that, we first need to understand what developer experience is, right? Developer experience, or DX in short, it ultimately describes the overall set of feelings and perceptions that a developer has while interacting with a technical product. And interacting normally has a twofold meaning as well. Whether the developer is using your product, for example, if the product is an API or a software development kit, an SDK of some sort, or if and like developers are ultimately your consumers, or if the developer is the one creating the product, example, if it's an app, or the developer is someone that's essentially making the company's internal tooling. So these are areas where someone would normally be dealing with developer experience. And in today's talk, I'll primarily be talking about developer experience for internal users. So from a high level, right, developer experience, it's the overall set of steps of building and shipping software. And this usually ends up including three large components: the people, process, and tooling. If you think about the last time you started developing a new feature, it was normally a product manager or someone of that sort that created either an epic in a software like Jira that gets broken down into a bunch of tasks and stories. Our developers will pick up arbitrary tasks, they'll start working on it. You figure out which service or which repository you want to start working within. And after that time, like you'll write some code, you'll debug, test, compile everything locally, you'll push it to some environment, and ultimately it ends up getting shipped to the end customer. And like for an experienced developer, this the mapping out the dev process at the very least mentally, many can actually do this in 15 to 30 minutes. But in our experience in working as engineers, getting this shipped to the ultimate end users, especially to 100% of the target audience, that oftentimes takes weeks. And this is true for most engineering teams. If we start to introspect the developer workflows a little bit, notice that there's this constant edit, debug, build cycle that we normally encounter. In most large systems, again, as I was just saying, the dev workflow starts, then you have testing, then CI, CD, your change gets pushed into some environment. Hopefully there are no issues, but often there are. You identify the issues, then you go back into this edit, debug, build cycle. Then there's usually the code review process. If a colleague wants to see some changes, we make the change, and then we're back into this edit, debug, build cycle. Then there's something like CI. Again, if there's an issue over there, first you need to understand how you can reproduce the CI build on whatever environment, usually a local environment that you're working in. And then again, the edit, debug, build process comes back. If something's wrong in CD, like as you're trying to deploy the application into some environment, it's the same set of steps over and over again till the software is actually running in production. And then we go into the normal maintenance mode usually. With this, maybe Maria, if you could send out the first poll, and our attendees might be able to like essentially participate with us as well then. Thank you. So jump to the next slide while folks are answering that question. So I tried to take the liberty to map out some of the common hurdles that engineers will experience when working in teams, right? Engineering ramp up is always a problem. And no, this isn't like normally just setting up your dev environment, right? It's understanding how the company's software systems, how everything works. This is very important. And if you don't understand how the systems work, you can't really make any changes to it either without breaking the rest of the system. Subsequent to that is understanding source code ownership structures and what processes different dev teams are taking within the companies. And a lot of the engineering work usually is very indivisible, like breaking up a single unit of work between two engineers often might end up taking more time than it would take one engineer. And like this, especially for folks that are dealing with tangible goods like selling cars, etc., on a daily basis, this might seem crazy. And then there's obviously the communication aspect, right? This is an Achilles heel for many engineers. Communication is hard, and especially harder in the remote world that we live in today, right? Having to balance various time zones. We obviously have attendees from various parts of the world today. Perceiving body language over Zoom is very hard. And just generally, coordinating technical work, even when everyone is sitting in the same room, is a hard process. And in a remote world, this becomes even more complicated. So with this, I just talked about the inner loop, right? I talked about the inner loop of development. And now I'm taking a little bit of, I'm just making up a few sample data points just to demonstrate how important optimizing the inner loop of the software development lifecycle is. Typically, let's say an engineer is coding for 6 hours in a day, right? Which is about 360 minutes. And at that point in time, the local loop is coding, compiling, and inspecting, right? And just taking from some rough sample points, you'll see that this bit is taking about 5 minutes. And as soon as you nowadays, many teams are using things like microservices. They are deploying their systems to fancy workload management systems. And within these, obviously in the container loop, you still have to build the normal binaries, but then you have to build a container image that contains that binary. And then container builds are sometimes pretty slow. Normally, you then have to push the image into a registry and then deploy that image. So now this inner loop, which used to be 5 minutes, so generally we'd be able to do about 70 or 72 of those cycles in a normal working day of 6 hours. In this new loop, it's about 40 to 45 iterations that we can usually go through. And that's a pretty large increase that we see. And obviously, the 9-minute loop that I'm talking about here, it's a very, very extreme case. But normally, even the 5-minute one, right? We can only ever iterate on the same bit 72 times during a single working day. So what is the impact from all of this, right? I was actually reading this report called the Developer Coefficient by Stripe, which they published about about 3 years back at this point in time. And ultimately, what we are learning from that is the impact from these inefficiencies in the dev workflows. They actually have a very, very large, close to a $300 billion impact to the global GDP every year. So while it is a priority for many of the executives and engineering leaders in the company to increase the productivity of the developers, normally what we see is the average developer will spend about 17 hours a week dealing with various maintenance issues such as debugging, refactoring, etc. In addition, they will also spend approximately 4 hours a week just fixing bad code. And this is 21 hours out of a 41-hour work week. And this is ultimately equating to about an $85 billion about $85 billion worldwide in the opportunity cost that's essentially lost annually. And this is based off of Stripe had some calculations on the average developer salary by country that they have also incorporated into the survey. So, another thing, I highly recommend checking this study out. It also said that about 2/3 of the developers agree that this is really excessive, right? And their sentiment was that clear prioritization and assigning responsibilities and longer-term product goals should help increase their own productivity in operating within the companies that they work at. So now, how does developer experience map to developer productivity? If the experience of developing software is good, then the throughput of producing that software usually goes up. We developers, we join companies to do good work. We care about the mission and the learning opportunities that we'll gain in service of that mission. And fundamentally, developers also have a high bar for quality. And we have this inner gauge that tells us whether a certain product or a feature that we shipped, if it's indeed good or not. And when the experience of developing software is delightful, we fundamentally end up shipping more. I was reading about Brooks' law of software management recently, and one of the things it stated over there was like adding more engineers to a late project will usually make it even later. And if anything, adding more cooks to the kitchen usually ends up lengthening the cooking time. So we shouldn't assume a simple linear and directly causal relationship between developers and as input and software as output. And I will contradict myself a little bit in the upcoming slides, but then I'll tie it all back. But in that book, right, in that book, Brooks' Law of Software Project Management, it stated that when scheduled slippage is recognized, the natural and traditional response is to add more people into the mix. It's like dousing a fire with gasoline. It usually makes the matters like everything way, way worse. And more fire requires more gasoline, and thus we end up in this regenerative cycle, which ends in disaster. So this is a little bit of data that I pulled up. It's a little dated from 2017, but Git Prime and now Pluralsight, they had put out a survey. And a lot of these data points, I'm sure, will continue to hold true for us in today's world. Meetings, we all know it's a big time drain. And there's also aspects of this, right, where we have to wait on other engineers, be it for code reviews or feedback, or in certain cases, waiting for clusters or environments to be available or ready, or maybe even having to debug or detect issues that are related to various environmental configurations and misconfigurations. And so now on the right-hand side, like when the person that makes the various tooling decisions in the company doesn't have a good understanding of the root cause behind a lot of these issues, this doesn't help at all. And usually what we see is this will end up resulting in further fragmentation of the SDLC. So let's try to understand developer productivity from the perspective of the actual user, like the developer, which is the goal of this stuff. If the experience of developing software is good, throughput of producing software goes up. Like we've joined companies to do work, we care about the mission, and we just want to build new features and ship them to end customers. So looking at it as a plain equation, when you hire developers, engineers, you get software. Developers create software. And as engineers, we'll normally write the software, we package it up, we put it on servers somewhere, and then real customers and users can hopefully start to derive some value from it. A key input to creating software, therefore, is developers. And if you break the software production function down, it's usually a product of developers and software over developers, as we can see. And taking a few lessons from Econ 101, if we just look at the intensive margin over here, which is the idea production function, that's productivity, generally speaking. So if we want more software, there's normally two ways to achieve that. Either get more developers or get more software per developer, which is ultimately greater developer productivity. Maybe with that, Maria, if you could send out the second poll, that'd be great.
Cool, but do you want to read out the results from the first one, or? I'm sharing it now.
I can try to find it somewhere.
It should be on the main screen in Zoom. So I can quickly read it out. For the first answer, developer environments that are symmetric to production, 70%, then removing local laptop resource limitations, 35%, ephemeral dev staging environments, 20%, ability to test against proper environments in CI, 30%, and then measuring software delivery metrics, 45%.
Very good. Thank you.
And the question was, what would bring the biggest change to your software development experience? I'll stop sharing this one and let me launch the second poll.
Thank you.
It's live.
So yeah, as we are talking about just general productivity, the goal over here, as 45% of the attendees today have said, some sort of being ability to measure software development metrics. So it'll be great to know how folks are dealing with this problem wherever we looked at it. A general sentiment, right? Every project or company, it usually starts with one developer. And as more people show up, more complexity gets added to the system. Ultimately, like productivity is something that declines over time. And in order to drive a little deeper, we perhaps need a solid rubric for to grade ourselves against, right? And this leads to the nebulous world of measuring developer productivity. But before I dive too far into that, it's important to understand what software even is, right? If it's a factory produces goods, but with software, the goods that are produced, it's usually not tangible. Generally speaking, in the world of tangible goods, right? So be it computers, planes, cars, clothes, etc. When you make a copy of something, the replicas, they ultimately end up adding value. And net value can be directly connected to the gross units that are produced. But in the world of intangible goods, which is like ideas, patents, software, and just various sorts of research, the marginal cost of replication is very low. It's so low that the replication in itself adds no value. If you think about it, right, replicating in the software world is essentially a Git clone. Super easy, and it doesn't really add very much value. So in the world of intangible goods, the value comes from a combination of novelty, impact, and execution. Why is novelty even important, right? So economic evidence will suggest that, like, unlike physical goods, idea productivity tends to decline over time. And the intensive margin that I was talking about of that software or idea production function, which is essentially the number of new ideas that an engineering or a product team can help solve, it'll fall dramatically as a company or a project progresses over its life cycle. And taking this, like this way of thinking into a more defined and mature field like that of research, in this case, the intensive margin of the idea production function, which is again the number of new ideas generated by a given number of researchers, this also falls dramatically as the field progresses. What we can see over here is, as compared to 1971 and comparing that to essentially 2014 over here, we need 18 times as many researchers to get the same 2x increase in the number of chips on a circuit board every 2 years. And then over here, the aforementioned one, I was essentially referring to Moore's law. And Moore's law is essentially the observation that the number of transistors in an integrated circuit, it'll double about every 2 years. And this observation is something that has held true for a pretty long time, right? Close to 50 years at this point. So taking these two bits, right, I'll go back to the previous slide once. So we can see that we have had a constant increase in the number of researchers, and we have seen that the output has stayed pretty constant for about 50 years at this point. So idea output is constant, growth in the number of researchers. This would fundamentally imply a shrink in research productivity. So if the flow of new ideas in semiconductor manufacturing is constant, which is evidenced by Moore's law holding roughly steady, and the number of chip researchers have increased over time, then simple arithmetic tells us that research or idea productivity has fundamentally declined over this period as well. So extensive margin adjustments, right, which is essentially adding more researchers into the mix, it's usually way simpler or easier. So we usually end up adding more researchers to increase output. Very similarly, in most engineering teams, we add more developers to increase software output. And it's very important to understand that both of these, like neither of these can be taken to an extreme. So there has to be a balance that's maintained over here. Tying it all back, as we just talked about, most of the innovation will usually happen in the inner loop of the SDLC. Like that's where the impatient engineer just wants to write code to get some of the ideas from their head into software, get it built and get it, do some testing that's end-to-end and get it deployed to end users. The inner loop of the SDLC, which is essentially our idea production factory, the developer productivity bit. That's why that requires a lot of deep introspection to fix. So there's a lot of companies that I essentially get to talk to on a day-to-day basis. And these are a few of the larger ones that I've seen have taken, they're essentially leading the market into how software development teams should even operate generally. And I used to work at Uber. And Uber had more recently actually had put out this project called Devpod that I'd helped contribute to. And the whole idea behind that was, again, setting development environments, as a bunch of folks in the poll also suggested that would be of help in their day-to-day engineering workflows. So now with this Devpod project, yes, Uber ended up achieving a large amount of developer satisfaction, but the Devpod project in itself, right? That wasn't the only thing that ended up achieving these goals, because if you look at the larger developer platform at Uber, like the overall developer experience workflows, there are projects like SourceGraph that are used for code search. CI has a concept of being stateful because pulling fresh images from the Docker registries or wherever else at all times isn't the most efficient thing to do. So that is usually at Uber, that is achieved using build guide. Uber built its own internal CD system. It's a thing called submit queue. That has a bit called conflict analyzer, which understands which pull requests might have conflicts with which other systems. There's another tool called Cerberus that allows developers to integrate with staging services from Dev or CI. And then there is the Devpod, which is a pretty, it's a fantastic tool. It's a customized and templatized dev environment, which connects to your local IDE. And now, with the click of a button, you have a fully working dev environment. But as we can see in a company like Uber, right? Uber is in the rideshare and food delivery business, but at the same time, it also ended up investing a lot in internal developer productivity software. And these components of developer experience have to be a part of any developer workflow, or rather the workflow of any large engineering team. So how can we enhance developer productivity, right? Maybe this is a section where I need to be a little precise, like new productivity tools that are thoughtfully applied. It usually makes developers more productive. But as we can see in the J curve from the first diagram over here, that productivity may not immediately realize. And it could be due to a combination of factors. Could be because developer productivity is fundamentally hard to measure. Like, what should you be measuring? Commits, lines of code, shipping number of releases every week or every month or every year? It could be one of those, or it could be because new tooling, it takes us a little bit of time to adjust to it. And this only reinforces the importance of investing sooner. That way, the trough that we see in the period of disruption, that can essentially be front-loaded. So now, I don't know how many folks in the attendees have taken classes like Econ 101, but generally there's a concept of supply and demand curves that are covered there. And normally what we see is higher productivity. It'll push out the developer demand curve. And as a result, companies can take advantage of this enhanced productivity and then use that to hire more developers. And in some cases, the enhanced productivity will not only make the existing developers more productive, but it'll also lower the bar enough that others can now become software developers too. And this is something we can see with the modern advent of like all of the GPT and AI stuff happening. A lot of the very simple coding related tasks have become significantly easier now, thus lowering the bar to entry. And this, again, pushes out the developer supply curve, and which fundamentally results in an increase in employment. So if you look at how software is normally built, right, the output is software running in production, and that normally comes from the dev stage, which is creating software. And the dev stage in itself will have a bunch of different facets to it, right? As I was taking the Uber example before, there's obviously the dev environment. There's a set of service catalogs, so engineers know what sort of systems that they can interact with, either for their dev tooling needs or for the, whatever feature that they're developing. There are usually certain concepts of dev clusters, staging, QA, etc. where folks will normally test their end-to-end features. There's a code review process to get feedback from colleagues. And obviously from the product management side, there's task tracking tooling that is normally used in the dev stage. And then from the testing standpoint, there's obviously things like CI/CD, where we can test whether the functionality has really been achieved. And then there are staging clusters where people can test software running end-to-end. So this is the initial bits of the SDLC. Then we have essentially the other aspect, right, of actually having software running in production. And this is where we normally think about things like reliability and security. And in reliability, there's a large component of observability. So where's my logging, monitoring, etc. When an incident happens, how is that usually remediated? There's a large aspect of configuration management, feature flags, etc. And obviously, there's the deployment aspect, which is like CD, which pushes changes into this environment. And on the security side, there's obviously things like permissions and then various data security related stuff. All of these is, and getting a sentiment of all of these to work in the dev space or the dev stage of the SDLC is usually a challenge. So maybe with this, Maria, if you want to read out some of the results from the previous poll, and if we could do the new poll, that'll be great.
Cool. So the previous question was, what metrics are you using to evaluate developer productivity at your company currently? We have 39% for DORA metrics, then 6% for space framework metrics, number of PR per dev per week, right? 22%, number of releases per week, 28%, number of commits per week, 17%.
Awesome.
Let me end the poll, and poll number 3. Sorry.
Yeah. So this is essentially to understand, I'm sure a lot of folks over here have been thinking about their internal developer experience infrastructure. And this is just so we can understand what areas of the SDLC people are thinking about more and where they would like to see more changes happen. With that, let me again go back into the impact, right? The impact from having various dissimilarities in environments and the inefficiencies that this introduces into our SDLC. And for what it's worth, as engineers, because we are interacting with the same set of systems day over day, we ultimately end up getting pretty normalized to this way of working. So development processes, obviously, they are pretty inconsistent and bespoke, right? A lot of development is still happening on local laptops. And there's no way to essentially get production to run properly in a local laptop. And oftentimes that might not be important either, but even getting a subset of it to run on your local computer gets pretty hard. So how does that component of the SDLC normally look? So in things like production, you would have, imagining a company is using things like Kubernetes, you have your deployment YAMLs, your Helm charts for on the more serverless Lambda side of the house, there's CDK, this, that, and the others. So there's a bunch of production system configuration, but that doesn't map very cleanly to either CI or local development necessarily. And sometimes CI does have a flavor of building a Docker image or some sort of a container image and then running it, but this happens pretty rarely. And then for dev and for most CI workloads, people will resort to using things like Docker Compose just to get a sentiment of getting your production sort of at least the network calls and the dependency graphs in place. But even with things like Docker Compose, right, volume mounts, etc., things have to get custom built into every image. Then you have to instruct the developers on how they can run their apps after making a change. Some folks will introduce things like file watch, but often the build happens on Mac OS and the container is running some flavor of Linux, binaries break a lot. There are various issues with UIDs, etc., etc. So the dev workflows aren't as streamlined as a production workflow might be. But ultimately, right, as we were also seeing in the second poll, ultimately by measuring developer metrics, we are basically trying to think about optimizing the cycle times of development. this is the aspect of measuring developer experience. And if you think about it, there's, as I have the image over there, the cycle of software delivery is, as an engineer, you propose a small change because smaller changes get quicker code reviews, the PR moves faster, and that overall process is less painful for the engineer. It's easier to deploy that change. As a result, you can do that bit more frequently. Now, what is the smallest PR you can have? It's no PR. If you go to that extreme, it obviously doesn't hold. But usually, a PR that's between 150 to 250 lines generally is what I've seen seems to go through this process the fastest. And one thing we need to understand is a majority of the software that most product companies will end up shipping to production, most of it doesn't work. Right? Like either it'll not add value or it might even add negative value. And recently I was hearing that many engineering leaders are saying that about 70%, it might be as high as 70% of the software that they write that doesn't add very much value at all. And from what we saw at that Moore's Law deep dive, it's like the novelty of software or ideas or research. It comes from constantly shipping incrementally more amounts of that idea or software, right? So what are the frameworks that a lot of companies are now starting to adopt? And some of these things have started to come out in the market from maybe 2020, 2021. It started with Google Cloud putting out the DORA framework, which is the DevOps research and assessment. So on the left-hand side over here, they have some, I added some metrics from that the Google Cloud team was internally measuring in 2019. And those are the 4 aspects of DORA, like the deployment tree. How quickly can I get changes out? And the second one is when bad things happen, how quickly can I recover from it? And often, as we can see, they had also added a framework around what the elite teams are doing versus a somewhat lower performing team. And more recently, the space framework has come about, which takes a slightly less activity-driven model to it and also starts to ask questions about essentially the developer working environments. So I saw that not a lot of people have investigated the space framework yet, so it might be good to just take a look and think about how you might want to integrate that into your company's workflows. So to essentially get close to wrapping, I will just talk a little bit about what I think the future of the software development lifecycle is going to start looking like. So in the dev stage, right, on the left-hand side, you see the current state of the world that people normally have to go through, like all of this setup stuff. You have to wait for your IDs to index and like builds, tests to run. CI gets slow. You have to build container images to test in a shared environment. Issues happen, and this is essentially the inner loop of the SDLC, and it's just too inefficient today. The world I think we'll end up in is, as a developer, I should just be able to click a button and get to a world where I can get to some environment where I can just write my code, test immediately, fix my issues. So the inner loop is much shorter. Very similar to how you would like click a button to get into a new Google Doc or something similar. And the code review process, again, like for like a more diligent code reviewer, they normally end up cloning a proposed change into their work environment and then get everything set up to start to identify issues and then like either leave comments or approve the changes. So like these flows also need to become much easier, because the code reviewer today, why do changes sit in pull request queues for a long time? It's because like just the overall context switching and then figuring out what's going on in the chain, like that process just takes too much time. It's too mentally draining for the reviewer. In a new world, I'd expect a bunch of automation in this space as well, where you can just click buttons, go to preview environments and something of that sort, and just see an end-to-end flow working. The CI/CD flows, again, normally in CI, as I was talking about, a lot of the Docker Compose heavy systems, it's really not, it adds value sometimes, but often whenever an issue happens, engineers will end up losing more cycles than they gain. So getting to a world where very production symmetric environments are also available in things like CI, and CD is way better integrated into the CI process, is something we'd expect to see. And then it's all these shared tenancy environments, right? Alice might be working on an API gateway change. Bob is testing out the database schema update. And then Charlie might come and try to fix a container or some service in the middle. And now arbitrary things start to break. And if we have a sentiment around ephemeral environments, all of that, all the environmental misconfigurations and drift, that'll start to also go away. So yeah, with that, I know we covered a lot of different topics. I don't know, Maria, if you want to just read out the results from the last poll and then we can wrap up.
Sure. Let me do that in the poll. So the question was, in which area of developer experience infrastructure do devs want better tools? So we have 20% for AI support for SDKs and code generation, then 60% for realistic ephemeral environments, 40% for API infra and management, and 40% for source control, code review, and search.
Somewhat unsurprising, and that makes a lot of sense.
Too protective.
But no, yeah. But no, thank you everyone for attending this today. Thanks for listening to me, and thank you, Maria, for emceeing this entire thing. And for what it's worth, we are doing a bunch of similar work in a similar space at DevSeed. If you're interested, feel free to check it out there. As Maria mentioned before, I'm there in the platform engineering Slack channel. So if you have any questions after this, I'd love to chat.
Amazing. Thank you so much, Debo. And we do have questions. So let's start from this one. Curious to know, is platform engineering a fancy name for internal tooling? How can we cultivate importance for such areas in a non-tech company? Because it's hard for the stakeholders to see the value. What do you think?
Yeah, so essentially, short answer is yes, right? Because all of these companies come up and you have to come up with your own fancy terminology for like marketing, et cetera, et cetera. But at the end of the day, if it's a non-technical company, I think just generally in this space, reinvesting, it takes a lot of time and effort to build tooling like this internally. We had seen how much money and time was spent when I was working at Uber as well. Generally, it's good to find a well-positioned vendor in the space and understand how their solutions might be able to help with the internal problems that you're facing. So yeah, and then like usually there's developer productivity, which is a software metric. And then usually you'll also end up seeing things like proper costs, like cloud costs, that usually gets pretty high. And especially in times like the ones we are living in right now. So if the vendor or platform provider can help demonstrate some of those cost savings also, usually what I see is, regardless of whether it's a technical or a non-technical company, like at least someone at the level of the CFO would be able to see a bunch of benefits from that.
Nice. Next question is, how important is it for dev tools to be adopted bottoms up? Are these successful dev tools that are driven top down through an engineering organization?
Yeah, so that is usually as a developer tool, right? Because as developers, if someone asks us to turn right, we normally turn left. We don't like being told what to do. Most developer tools that have had good adoption, it's always been bottom up. One aspect that we saw at Uber was especially around the cloud hosted dev environment aspect of Devpods. There was a pretty, at the VP of engineering level, there was a sentiment around like, this is how it needs to, as a company, onboarding, etc., security, those things were very important. And as a result, that was the direction we had to go in. The first couple of quarters, the tooling just wasn't at the standards that the engineers wanted. As a result, adoption wasn't that high. But after a while, like when engineers slowly start to see the value of the platform, the bottom-up adoption is the only thing that will work. The initial funding and the initial support in those cases comes top-down. But I think, yeah, most developer tools has to be bottom-up, right? Because that's where the value has to be felt. The developer uses something, gets value, and then keeps using it.
And just out of curiosity, so for example, let's say developers start engaging with the tool, right? Like, but they don't have budget. And then that budget decision, it comes with the C-level, with the top. So what do you do in this case?
Yeah, so like normally what I've seen is I was actually one of those developers at Uber when and it was around 2019, 2018. It was this product called Sneak, where we were using it, we were pretty happy with the tool, and ultimately then it starts to be a conversation around, this is a problem that needs to be solved. This is how much it might cost to build it internally. Let's talk to Sneak and figure out the right way to partner up, because you might not have a lot of budget in a given year. You might have something in the future years, but it's more important to like just continually derive value from using the product, and then the money can come. Like maybe some of it will come this year, some of it will come in the next years. There's usually if there's strong enough of a pain point, if there's truly a hair on fire problem, like a tennis racket also makes sense sometimes, right? If a pail of water isn't available. So that's just how we think about it.
Got it. Yeah, guys, I saw someone asked about the slides, and so slides we'll share tomorrow with the webinar replay. So that will be in your inbox with the email that you signed up for this webinar. By the way, we had this question about the last poll was about in which area of developer experience infrastructure do devs want better tools. So actually next week we're going to have the webinar about, it's not about the tools, but enabling PR and ephemeral environments at enterprise scale. Something you want to join in next week, and you will also receive the webinar registration page with the follow-up email if you are interested. But other than that, I don't have any other questions. I didn't see any other questions in the chat.
Right.
So that, I guess that will be it. Thank you so much, Debo, for...
I think Richard might have one more question. I just saw that.
You're right. Let me read it out. One more question. What's the question, Richard? We are waiting for it as you're typing.
It'd be funny if Richard types the question character by character and keeps sending us each character.
No. Is there a model for computing the value of investment in such a capability? How do you quantify and sell upstream?
So Richard, because developer productivity is usually a bunch of software metrics put together, right? So there's obviously the underlying hardware cloud cost component that can be represented as a solid metric that's moving. There's also things like cycle time, etc., and a few of the DORA and space framework metrics that we talked about that we have seen various engineering teams track. And you make an argument around like, if I invest in this, I can see that a certain tool is helping me improve my cycle times, and as a result, I'll be able to ship more product, etc. Normally, what I've seen as software metrics will get sold in that way, especially to the higher ups. I hope that answers your question.
Cool. I think it does. Thank you so much, Debo, again. Amazing presentation. We'll send our slides and webinar replay tomorrow to everyone. Yeah, Richard is asking to take it offline, so you know where to find Debo, Platform Engineering Slack channel. Hope you signed up. Let me send you the link once again. Just join Slack and you will see the last post in general will be around this amazing session. Cool. Thank you to everyone who joined today. We'll see each other next week, and hope you have amazing end of the day. Ciao. Bye.
Thank you so much. Bye.